Welcome to the first lesson of college algebra, and that is solving linear equations in one variable. An equation of this form is ax plus b equals c, where a, b, and c are real numbers, with a not equal to 0. So the key thing is that the variable in the equation, this x, has an exponent of 1, and everything else is a real number. Because the exponent is 1, we also call these equations first-degree equations. Now, a value of the variable that makes an equation true is called the solution or root of the equation, and the solution set is a set that contains all these solutions, and we write them with braces. So here's a very simple example. If I have that x plus 6 is equal to 10. To solve that equation means to find the value of x that makes this a true statement. Well, we know that 4 plus 6 is 10, so the solution x must equal 4. Therefore, we write the solution set as a set containing 4. Now on this screen I have an example where we will test to see if we have a number that is a solution of the equation. And that's the great thing about solving equations, is that you can check your answer and know if you're right or wrong. The first equation is 2x minus 6 equals 7x plus 4, and we want to determine if negative 2 is a solution. To do that, we will replace our variable x with the negative 2. So that gives us 2 times negative 2 minus 6. Is that equal to 7 times negative 2 plus 4? Well, 2 times negative 2 is negative 4 minus 6 is negative 10. On the right, we get negative 14 plus 4, which is also negative 10. So because negative 2 made the equation a true statement, it is a solution. So the solution set would be the set containing negative 2. Our next equation is 1 minus x divided by 5 equals 6. We want to determine if negative 25 is a solution of that equation. We'll plug in negative 25 in place of x. This gives us 1 minus negative 25 divided by 5, and we want to see if that equals 6. Remember your order of operations. You want to do the division first. Negative 25 divided by 5 is negative 5. So this becomes 1 minus negative 5. Is that equal to 6? And that's true, right? And that's really 1 plus 5, or 6, equals 6. So the negative 25 gave us a true statement. Therefore, the solution set consists of the number negative 25. Now, there are equations that we'll cover that are not linear equations, and we call those non-linear equations. Here are a few examples. The first one is x squared minus 2x equals 0. Do you see the reason that this is not linear is because the variable has a power of 2. So the exponent is 2, which makes that a non-linear equation. The second equation is 3 divided by x minus 5 equals 4. Well, this is not linear because there is a variable in the denominator. And then we have square root of x plus 1 equals 5. And again, this is not linear because there is a variable inside the square root. Now, not all equations will be as easy to solve as the one that I demonstrated on the first slide, right? X plus 6 equals 10. That was pretty obvious what the solution was. So we have to perform some steps to each side to eventually come up with an equation of the form x equals some number. And the process of doing that is creating a set of equivalent equations. An equivalent equation is an equation that has the same solution set. And there are two properties that we can apply to produce an equivalent equation. And that is the addition property of equality and the multiplication property of equality. These two properties basically say that what we do to one side of the equation, we have to do to the other. If you think about a scale, which we probably don't use much anymore, but think about two things that are equal in weight. If I take something off of one side of that scale, it's going to be imbalanced. So to keep it in balance, I have to take something off the other side of the scale as well. So whatever I do to one side, I have to do to the other to maintain the equality of those two expressions. So I can either add or subtract the same number from each side, or I can multiply or divide each side of the equation by the same non-zero number. So the steps to solve a linear equation is I want to simplify each side as much as possible, clear parentheses by applying the distributive property, combine any like terms. Then if I have fractions, I want to remove the fractions by multiplying each side by the least common denominator. And then I'll use the addition property to get all of the variable terms on one side, all of the constants on the other. Then the multiplication property of equality will enable me to get a coefficient of 1 on the variable. And then I can check my solution and write the solution set. If any of these steps sound unfamiliar, please be sure to check out the prerequisite skills section to remind yourself about multiplying by the least common denominator, combining like terms, and so forth. So we'll work a few examples now. The first example is the equation 2 plus 2 times the quantity x minus 3 equals 5 times the quantity x minus 7, then minus 2. So we see there's a lot of x's here. There's a lot of things going on in each side. Our first goal is to rewrite each side in its simplest form, clear the parentheses, and combine like terms. So on the left, we're going to write this as 2 plus, now distribute. This would be 2x minus 6 equals, on the right, distribute the 5 to get 5x minus 35, and then minus 2. We can combine like terms to get 2x. 2 minus 6 is minus 4 equals 5x minus 35 minus 2 is minus 37. So now we need to get to the variables on one side, the constants on the other. And so if I want to eliminate the variable from the right side, I need to subtract it off. So I will subtract 5x from each side, remembering that what I do to one side, I have to do to the other. So I'll subtract 5x from each side. 2x minus 5x is negative 3x minus 4, and that's equal to, well, now the 5x minus 5x is 0, and then minus 37. So now to solve, I need to get the x term by itself, means I need to remove that negative 4. So to remove negative 4, I can add 4, and I'm doing the opposite. So I get negative 3x on the left is equal to negative 37 plus 4 is negative 33. And now to solve for x, you have to be careful here. Notice that x is multiplied by negative 3. So to remove it, I need to divide each side by negative 3. And therefore, x is equal to negative divided by negative is a positive 11. If I want to check my work, I could plug the 11 in to each occurrence of the variable, see that I get the left side equal to the right side. I'm going to trust the process right now, and that would tell me that the solution set is the set containing 11. In part B, I have the equation 3 times the quantity x minus 5 minus 4 times the quantity x minus 3 equals 7x plus 3 minus the quantity x minus 1. If you want to pause the video and work this through to check your understanding, that would be great, and then resume it when you're done. So to solve this equation, we distribute on the left to get 3x minus 15. And then be careful here, we have a negative 4 that we need to distribute. So that will go into each of those terms to get negative 4x plus 12. And that equals 7x plus 3. And then the minus in front of the parentheses suggests that we want to take the opposite of, which is equivalent to multiplying each term by negative 1. That gives us minus x plus 1. Combining like terms, 3x minus 4x is a negative x. Negative 15 plus 12 is minus 3. And that equals 7x minus x is 6x. 3 plus 1 is plus 4. So we can take our variables to the left or right. I'll take them to the right at this time, just to show you a different approach. If I want to move the variable to the right, I need to remove the negative x from the left side by adding it to each side. That gives us then just negative 3 equals 7x plus 4. Now I need to move the 4 to the left, and I can do that by subtracting 4 from each side. This gives me negative 7 equals 7x. And so to solve for x, I need to divide by its coefficient of 7. Negative 7 divided by 7 is negative 1 equals x. And again, I could plug the negative 1 in to check that I have my solution correct. But the solution set then is a set containing negative 1. Two other examples. Again, if you want to pause and work these through, that would be fine. Part C is 2x minus 2x divided by 7 equals x divided by 2 plus 17 divided by 2. This equation is a linear equation because the variable is raised to the 1 and it's in the numerator of these fractions. The first step I want to do is to clear the fractions by multiplying each side by the least common denominator of 14. So if I multiply the left side by 14 and the right side by 14, that 14 distributes to each term of the equation. 14 times 2x is 28x. 14 times 2x over 7. Well, 7 goes into 14 2 times. 2 times 2x is 4x. So that's really 28x minus 4x is equal to x over 2 times 14. 2 goes into 14 7 times. 7 times x is 7x. 17 divided by 2 times 14. 2 goes into 14 7 times. And 7 times 17 is 119. Combining like terms, on the left, 28x minus 4x is 24x equals 7x plus 119. Now I need to get the variables to the left, and I can do that by subtracting 7x. 24x minus 7x is 17x equals 119. So now we can divide each side by 17. And 119 divided by 17, we saw earlier, is 7. So our solution set is the set containing 7. Part D is the quantity 3x plus 2 divided by 5 minus the quantity x minus 3 divided by 2 equals the quantity x plus 2 divided by 3 plus 1. Because of the fractions, I need to multiply each side by the least common denominator of 5, 2, and 3, which is 30. So if we multiply each side by 30, I'm going to write this one out because we have to be careful with the numerator of that fraction being a binomial. So we would have 30 times 3x plus 2 divided by 5 minus 30 times x minus 3 divided by 2 equals 30 times x plus 2 divided by 3 plus 30 times 1 is 30. So we want to divide out the common factor first. So 5 goes into 30 6 times, and now distribute the 6 to the numerator, which becomes 18x plus 12. 2 goes into 30 15 times. Distributing, be careful with this negative. So negative 15 times x is minus 15x. Negative 15 times negative 3 is plus 45. And that equals 3 goes into 30 10 times. So 10 times x plus 2 is 10x plus 20 plus 30. So combining like terms, 18x minus 15x is 3x. 12 plus 45 is plus 57. And on the right, we get 10x plus 50. So now we need to collect our variable terms to one side, our constants to the other. We can subtract 10x from each side. So we get 3 minus 10x, or negative 7x plus 57 equals 50. And then subtract 57 to get negative 7x equals negative 7. And lastly, divide each side by negative 7 to get x equals 1. And our solution set then is a set containing 1. Now keep in mind, you can combine a lot of these steps into one. I'm just doing it so there's no question as to what happened. But please let me know if you have any questions on these examples.